Hello everyone, welcome back to the second video in our series. Today we are talking about hardness testing. You've heard of this term hardness. Now let's see what is it. Hardness is a measure of a material's resistance to plastic deformation. Essentially, uh, we we can understand higher the hardness, the stronger the material, right? So as the hardness increases, the strength of the material also increases. One of the most common ways of determining hardness is by indentation testing. So in an indentation test, we use an indenter tip, which is basically a non-deformable material, a material which is really hard. So some of the hardest materials what you can use there are diamond or silicon carbide or tungsten carbide. These are some of the popular indenter tip materials. What you then do is you have an indenter tip here. You press the indenter tip onto a material surface, so directly perpendicularly with a certain force, and what then happens is the material underneath deforms. You essentially then measure either the depth or the area or sometimes both, and from that the hardness value is derived. Some of based on the type of indenter tips and also based on the type of loads, there are different hardness tests out there, and some of the most standardized ones, the most common ones, what you know are Rockwell, which has like a diamond indenter tip in a conical form, having an angle of approximately, this conical form having an angle of approximately 120 degrees. And then a Brinell indenter, which is actually a spherical indenter, so it leaves like a spherical residual indent, something like this. And then you have Vickers, Knoop. Vickers is a prismatic indenter. Then you have Knoop, and then you have actually a Berkovich indenter here, but we are talking here in the nano indentation. Like I said earlier, the amount of load or the amount of force also varies with these tests. In the macro range, that's very high forces are used. You essentially then use Rockwell or either Brinell tests, and in the sub-macro, that is towards the less than 10 Newton, you would use Vickers or Knoop, or these are going to some micro Newton loads as well. And in the nano range, you would use generally a Berkovich indenter tip. Like I mentioned earlier, there is a correlation between what you derive the hardness value to the tensile strength of the material, and this is generally used in the industry by converting. There are some conversion tables and some formulas out there where you can convert the hardness value into tensile strength of the material. Let's look at some of the advantages and disadvantages of this technique. Some of the advantages of a hardness test: it's a localized test, that is, you can really get the material data in a very in a localized area, and you can see how it maps across the complete component. Suppose you have a component of this shape, you can measure the tests here. As these tests are quite small, you can completely map out the entire sample. You can see the properties here. The properties here, this side of the material could be very different from the properties on this side as well. Secondly, this is a really fast test. It can be done quite fast. It's a cheap test. The whole test and the preparation is not very complex. It's a quasi non-destructive test as well. That is, you're not really destroying the material. You're just making few indents which can be machined off later if required, and the material can be reused. What are the disadvantages? We spoke about the conversion table earlier. This is not accurate for all materials. Example, for aluminium or for titanium, these tables are not really accurate, and they're mainly used for steels, and again not for all alloys of steels. Secondly, you can have materials which have the same hardness value, that is, you will determine that it is almost equally strong, but it fails to give you the complete picture of the material property, like yield strength or strain hardening. So what you see here, material A and material B, they have very similar strength values. So you see material A and material B, they have very similar strength values, but they can have different yield points here, and it can also have different strain hardening. In the next video, we will see how we can combine the simplicity of indentation-based hardness test while trying to get the real material properties similar to that of a tensile test. Stay tuned and see you all in the next video.